So in this video, we'll be talking about the derivatives of trig functions, basic trig functions like sine x and cosine x, and we'll do a small introduction to the chain rule and how you can use it on functions. So it's not going to be a long video, but let's get started with this simple sine x function. So while there's no way for me to exactly demonstrate how this is the derivative without using graphs and stuff, it's good to know that the derivative of sine x is just equal to cosine x. That's it. So that's just stating that at any point on the sine x graph, the slope of the graph would be equal to cosine x of that graph, right? And that makes sense because sine x is just equal to cosine x, cosine pi over 2 minus x. So it's just a shift of pi over 2. And then it's good to know that the derivative of cosine x is equal to minus sine x. Okay? So those are the two basic trig functions. And of course we can calculate the derivative of tangent x, because tangent x at the end of the day is just equal to these two functions over each other, right? So just keep those in mind, and then for next videos, for future videos, when we talk about like when we're deriving tangent functions along with normal polynomial functions, it's good to have these rules in mind. So what do we do when we're deriving sine x squared, right? So it's not going to be like just cosine x squared or like something like that, because we found derivative sine x is cosine x. It's not going to be like that. Oh, that's very, very bad looking too. But I mean, it doesn't even matter, because this is not how we go about solving this question. Here we're introduced to the chain rule. So the chain rule states that for f of g of x, right? So that means when there's one function that's inside another function, the derivative of that function, derivative of this, would be equal to f prime of g of x times g of x prime, right? So let's first figure out what f of x and g of x are in this equation right here. So first of all, g of x would be the inside function. So what's the bare bones of this right here? So we have sine x is being squared. So g of x would be sine x because we're doing something to sine x, right? And then f of x would be equal to what? So when we put sine x into this equation, what are we doing? So we're actually squaring sine x, right? So that would mean that if you put, it would be x squared, because if g of x is equal to x, right, then that would mean that g of x is equal to sine x, which means x is equal to sine x, and that's what we're doing, sine x squared. So that's what each function is denoted by. So first, let's find, it's usually easier to find this number, the derivative of this number. So the derivative of sine x we figured out was, right, so the derivative of this would be equal to cosine x. So that's this portion. And then on this portion, let's just make some room. It would just be equal to, using the basic derivation rules we used from the last video, we can take the exponent, right, multiply it by the coefficient, so that'd be 1, that's why I wrote 1 just now, and subtract 1. Right? So that would just be that. So the final answer would be times cosine x. Sorry for that weird looking x. That'd be the final answer. Oops. Like that. Okay? So that'd be all for this video. In the next video, we'll be talking more about product and quotient rule, or maybe more about chain rule, because it's just a simple introduction. But yeah, thank you for listening.